242 billion euros. That number is not a budget. It is a wound. It is the combined cost of Europe's most ambitious engineering projects. Projects that were supposed to be finished years ago, sometimes decades ago. These are not small infrastructure jobs. They are tunnels bored through living mountains, rail lines threading across entire countries, bridges suspended over open sea. Each one promised to change how a continent moves. Engineers called them generational. Politicians called them visionary. Journalists photographed the groundbreaking ceremonies. That was then. Today, the dirt is still moving. The costs are still climbing. And somewhere in a government building, someone is rewriting the deadline. Again. So what exactly keeps happening inside these projects? And why does Europe keep building things it cannot seem to finish? To understand the failure, you have to understand the dream. In the late 1980s and early 1990s, Europe is in the middle of an identity project. The European Union is forming. Borders are dissolving. The idea of a connected continent, one where goods, people, and trains move freely from Lisbon to Helsinki, is no longer a fantasy. It is a policy. The Trans-European Transport Network, known as TEN-T, is born from this ambition. Its goal is simple. Build the infrastructure that makes Europe feel like one place. Rail corridors, road tunnels, cross-border bridges. 30 priority projects are identified. Each one targets a missing link, a place where geography or old borders have kept nations apart. The Lyon-Turin rail tunnel, stretching 57 kilometers through the Alps, promises to take heavy trucks off French and Italian mountain roads and put freight onto electric trains. It will cut travel time between the two cities by an hour. Italy and France signed the deal in 2001. The Brenner base tunnel beneath the Austrian-Italian border targets the busiest alpine freight corridor in the world. 55 kilometers of underground rail beneath the Brenner Pass. Engineers call it the deepest railway in existence. The Fehmarnbelt fixed link between Denmark and Germany promises the longest immersed tunnel on Earth, 18 kilometers beneath the Baltic Sea. It will reduce the ferry crossing to an 11-minute train ride. The Stuttgart 21 rail project in Germany aims to bury an entire central station underground, freeing up 100 hectares of prime city land and slashing journey times across southern Germany. Each project launches with detailed plans, confident timelines, and fixed budgets. Engineers present clean slide decks. Ministers shake hands in front of cameras. The public hears one message. This will be done soon, and it will be worth it. Across 4 countries, across 4 different projects, the same optimism takes hold at exactly the same moment. Nobody asks what happens when the optimism runs out. Construction begins. And for a while, just a while, everything looks like it is going to work. At the Lyon-Turin tunnel, exploratory boring starts in the mid-2000s. The machines are enormous. Tunnel boring machines, TBMs, are the size of small apartment buildings. They rotate slowly through rock at a rate measured in meters per day, not kilometers. Engineers already know the Alps. They have bored through them before. But each mountain range hides its own geology, its own faults, its own pressure systems deep underground. The Mont Cenis Massif between France and Italy is harder than the surveys predicted. Much harder. At the Brenner tunnel site, 2 countries co-fund a project company called BBTSE. Geological surveys take years to complete. Preparatory tunnels, smaller access shafts drilled to study the rock, reveal something unexpected. The mountain interior is fractured in ways the models did not capture. Hot springs appear where no water was expected. In Germany, Stuttgart 21 breaks ground in 2010. The city center is torn open. Concrete walls go up around the old station. The project looks dramatic and modern. Germany prides itself on engineering precision. The project manager states publicly that the tunnels will be complete by 2019. In the Baltic, the Fehmarnbelt Consortium studies the seabed. The plan is innovative. Precast concrete tunnel sections, each 217 meters long, will be sunk to the seafloor and joined end-to-end beneath the water. It has never been done at this scale. But the engineers are confident. They have done the maths. Across all 4 projects, workers move in. Steel arrives. Concrete is poured in quantities measured in millions of cubic meters. Progress is visible. Photos are released to the press. The tunnels are coming. But underground, invisible to cameras and press releases, something else is also coming. The geology is talking back. Nobody is quite listening yet. The Lyon-Turin project hits the first wall in the form of asbestos. The rock inside the Mont Cenis Massif contains naturally occurring asbestos fibers. This is not theoretical contamination. Every time the boring machine moves forward, it releases microscopic fibers into the tunnel air. Workers require full respiratory protection. Excavated material cannot be disposed of through normal channels. It is classified as hazardous waste. Special treatment facilities must be built just to handle the spoil. The cost of removal rises sharply. The schedule slips by months, then years. France and Italy begin arguing about who bears the additional cost. A project that should be entering its final engineering phase is instead stuck in a legal dispute about toxic dirt. At the Brenner Tunnel, the problem is entirely different: water. The exploratory tunnels hit underground aquifers at depth. High-pressure water floods access shafts. Pumping systems are installed. But the water table, disturbed by the boring, begins to affect surface wells in nearby Austrian villages. Local farmers complain. Environmental authorities launch investigations. Work slows while lawyers and hydrologists produce competing reports. Stuttgart 21 encounters a different failure mode: fire protection. In 2013, German Transport Authority engineers review the tunnel schematics and raise a formal concern. The tunnels as designed cannot meet updated EU fire safety standards for underground railways. Escape routes are too far apart. The ventilation system is insufficient for smoke evacuation during emergencies. The entire design must be revised. For the Fehmarnbelt project, the first problem is not underground at all. It is legal. Danish environmental groups file a lawsuit challenging the project's permits. A Danish appeals board rules that the environmental impact assessment is incomplete. Work cannot begin on the Danish side. Germany watches from across the strait. 4 different projects, 4 completely different first problems. Asbestos, groundwater, fire codes, environmental law. The engineers had solved for the geology they expected, not for everything else. This is where the projects stop being engineering problems and become political emergencies. The Lyon-Turin tunnel cost estimate, originally pegged at €8.5 billion for the main cross-border section, rises to €26 billion by the late 2010s. Italy holds a national election. The new coalition government, led partly by the Five Star Movement, announces it opposes the project entirely. They commission a cost-benefit analysis. The analysis concludes the tunnel will not pay back its investment for over 50 years. Italy freezes its financial commitment. France is furious. The EU is furious. A project involving 2 sovereign states, a European treaty, and 14 years of preparatory work is now politically unraveling because one partner government changed its mind. Stuttgart 21 faces something uglier. Tens of thousands of protesters occupy the construction site in 2010. Police use water cannons. Dozens are injured. A retired teacher loses an eye. The incident becomes known as Black Thursday and turns public opinion sharply against the project. A state referendum is held. The project survives, narrowly. But the political damage is permanent. The budget climbs from €4.5 billion to €8.2 billion, then to €9.8 billion. Each revision comes with a new promised completion date. Each date passes. Deutsche Bahn, the national rail operator managing the project, stops publishing firm deadlines. At the Brenner project, the cost estimate revises upward from €8.3 billion to over €10 billion. The Austrian and Italian governments reopen the financing agreement. New negotiations take 2 years. EU funding, which covers up to 50% of certain cross-border costs, is secured only after extensive lobbying. The Fehmarnbelt legal battle ends only in 2020 after a decade of litigation. But the delay has consequences. Supply chains planned in the early 2000s are obsolete. Equipment prices have risen sharply. The construction consortium must re-tender contracts. The total project budget rises to approximately €7.4 billion, up from the original €5.1 billion estimate. Each project is now carrying 3 kinds of debt simultaneously: financial debt from cost overruns, political debt from broken promises, and engineering debt from deferred design decisions that must eventually be paid back, in concrete, steel, and time. By the late 2010s, the crisis is no longer hidden inside tunnels. It is on front pages. In 2018, Germany's Federal Court of Auditors publishes a damning report on Stuttgart 21. The court finds that the project management has systematically underreported risks to Parliament. Cost estimates were optimistic by design. Officials knew about the fire safety problems years before they were disclosed publicly. The report states that Parliament was misled. A parliamentary inquiry begins. In Italy, the political paralysis over Lyon-Turin forces the EU Commission to intervene directly. European Transport Commissioner Violetta Bulc warns Italy that abandoning the project would trigger repayment demands on EU grants already dispersed. Billions of euros could be clawed back. The Italian government reverses course. But trust between Rome and Brussels is badly damaged. The Brenner project hits a physical crisis in 2020 when COVID-19 lockdowns halt construction across Austria and Italy simultaneously. Workers cannot cross the border. Supply chains stop. The boring machines go cold. Months of progress evaporate. When construction resumes, it does so under new cost pressures. Inflation in steel, concrete, and labor is running at rates not seen since the 1980s. In Denmark, the Fehmarnbelt project finally begins major construction in 2021, 11 years after its original planned start date. But the tunnel factory built specially to manufacture the 89 concrete elements is running behind. Curing times, quality checks, and design tolerances are tighter than the schedule assumed. These projects were not failing in isolation. They were failing in concert, under the weight of a planning culture that had promised more than any tunnel or rail line could deliver, on schedules that were never truly achievable. Governments try to fix what they can. The results are partial at best. Germany appoints a project mediator for Stuttgart 21, a respected former premier named Heiner Geisler. He runs a televised mediation process with engineers, politicians, and protesters. Some design modifications are agreed. Ventilation shafts are added. A stress test is conducted to prove the station can handle projected passenger numbers. The test passes, barely. Critics argue the parameters were designed to allow a pass. Construction continues. The Lyon-Turin project survives Italian political opposition through sheer treaty weight. The 2001 bilateral agreement between France and Italy has legal force neither government can easily escape. Work continues on exploratory and preparatory tunnels. But the main bore, the 57-kilometer heart of the project, has not yet begun. A new intergovernmental agreement is signed in 2023, reconfirming the project. The target completion date is now 2032. That is 3 decades after the original signing. The Brenner Tunnel brings in new project governance structures after the COVID disruption. Monitoring committees publish quarterly reports. Independent auditors review cost estimates. The completion date is revised to 2032. Funding agreements with the EU are extended. Work resumes on multiple construction fronts simultaneously to recover lost time. Progress is measurable. It is also still years from done. At Fehmarnbelt, the tunnel elements begin emerging from the factory. The first sections are lowered to the seabed. Progress is visually striking. Huge gray concrete boxes disappearing beneath the Baltic. But the factory's production rate is slower than planned. Each element takes slightly longer to cure, slightly longer to inspect, slightly longer to place. Slight delays, multiplied across 89 elements, become significant delays. Every fix creates new timelines. Every new timeline creates new risk. The projects move forward, but completion always seems to stay just beyond reach, like a horizon that retreats as you approach it. Today, none of these projects is complete. Stuttgart 21 is now expected to open in 2026, 16 years late. Its final cost is estimated at 11.5 billion euros, more than double the original figure. Some engineers still question whether the station will handle future passenger volumes. The Fehmarnbelt Tunnel targets 2029. Factory production is ongoing. The seabed is slowly filling with concrete. But the schedule has no margin left. The Brenner Base Tunnel aims for 2032. Preparatory tunnels are complete. The main bore continues. Cost projections keep moving upward as inflation bites. Lyon-Turin remains the most uncertain. Main boring has not begun. Political commitment exists on paper. But so did political commitment in 2001. Across these 4 projects, Europe has spent over 242 billion euros, waited over 2 decades, and built infrastructure that moves slowly precisely because it was never designed to fail fast and recover. It was designed to look inevitable, and inevitability, it turns out, is the most expensive material of all. The tunnels are still being bored, the bills are still being written, and somewhere right now, in a conference room above one of these construction sites, an engineer is looking at a schedule and quietly moving the date forward again. So here is the question that no completion date can answer. If Europe's most powerful nations, with every modern tool available, cannot finish what they started, what does that say about everything else they are planning to build?